Sometimes the universe sends us visitors that rewrite everything we thought we understood. Objects that shouldn't exist according to our models. Objects that force us to ask uncomfortable questions about what's possible and what's merely probable. For thousands of years, humanity looked at comets and saw omens, divine messages, harbingers of change. We've grown beyond superstition. We've learned to see them as what they truly are: frozen remnants of planetary formation, icy time capsules carrying the chemical signatures of star systems long dead. But what happens when one of those time capsules is older than a star system you're standing in? On October 7th, 2025, the European Space Agency released something extraordinary. Images captured by two Mars orbiters, ExoMars Trace Gas Orbiter and Mars Express, showing a faint point of light moving against the backdrop of deep space. The target was 3I/Atlas, the third confirmed interstellar visitor to our solar system, photographed from another planet for the first time in human history. The images themselves are remarkable, but what they reveal is genuinely unsettling. 3I/Atlas was glowing. A diffuse halo of light surrounded its nucleus, exactly what you'd expect from a comet being heated by the sun, releasing gas and dust as its ices sublimate into space. Every comet we've ever studied behaves this way. It's basic physics. But there was something missing, something that should have been impossible to miss. 3I/Atlas had no tail, no streaming plume of material blown back by solar wind, no characteristic comma-shaped coma, just a diffuse glow around a nucleus we couldn't even distinguish from the surrounding brightness. And when astronomers calculated the object's age based on its trajectory and chemical composition, they found something that challenges our understanding of cosmic time itself. 3I/Atlas may be 7.6 billion years old, 3 billion years older than our sun, older than Earth, older than everything in our solar system. This isn't just a comet. It's a messenger from a universe that existed before we did. The discovery didn't come from billion-dollar space telescopes or giant ground observatories. It came from an automated sky survey telescope in Chile, part of the Atlas network designed to detect near-Earth asteroids. On July 1st, 2025, the system flagged an object moving unusually fast through the constellation Sagittarius. Initial observations suggested it might be another long-period comet from the Oort cloud, the vast sphere of icy bodies surrounding our solar system. But when astronomers calculated its orbit, they realized something was fundamentally different. The trajectory wasn't elliptical, it was hyperbolic. This object wasn't bound to our sun's gravity. It was passing through on a one-way journey from interstellar space. The International Astronomical Union confirmed it as the third interstellar object ever detected, designated 3I/Atlas. The first was Oumuamua in 2017, a cigar-shaped object that exhibited unexplained acceleration. The second was 2I/Borisov in 2019, which behaved like a relatively normal comet. Now we had a third visitor. And this one was showing behaviors that fit neither of its predecessors. Within days of the initial discovery, every major telescope capable of observing faint moving targets turned toward 3I/Atlas. NASA's Hubble Space Telescope captured high-resolution images in August 2025. The Gemini Observatory in Hawaii used spectroscopy to analyze its chemical composition. Ground-based facilities across the southern hemisphere coordinated observation campaigns to track its motion with unprecedented precision. What they confirmed was extraordinary. What they couldn't explain was even more so. 3I/Atlas measures between 1 and 5 kilometers in diameter, roughly the size of a small mountain. It's moving at approximately 40 kilometers per second relative to our solar system, fast enough to cross the distance from Earth to the Moon in just over 2 hours. Its hyperbolic orbit brought it from the direction of Sagittarius, the constellation pointing toward the galactic center, and will carry it past the Sun, through the outer planets, and back into the depths of interstellar space. But size and speed are just numbers. What makes 3I/Atlas genuinely mysterious is what it's doing and what it's not doing. On October 3rd, 2025, 3I/Atlas passed within 30 million kilometers of Mars. That's close enough for detailed observation, but far enough to pose no risk to the planet or its orbiting spacecraft. The European Space Agency seized this rare opportunity. They commanded two Mars orbiters, ExoMars Trace Gas Orbiter and Mars Express, to point their cameras at the approaching visitor. The CASIS camera system aboard ExoMars TGO was designed to photograph the Martian surface in high resolution. It was never intended to image distant comets. Nick Thomas, the principal investigator for CASIS, described the challenge to ESA. This was a very demanding observation for the instrument. The comet is about 10,000 to 100,000 times fainter than our usual target. But the images were successful. For the first time in history, an interstellar object was photographed from the surface perspective of another world. The frames show 3I/Atlas as a faint luminous point against the black of space, moving steadily across the star field over 9 minutes of exposure. The images confirmed that 3I/Atlas is active. There's a diffuse brightness around the nucleus, evidence that the sun's heat is causing material to outgas from the icy body. This is normal comet behavior. Expected. Textbook. But here's what's wrong. The images show no tail. No extended plume of dust and gas stretching away from the sun. No characteristic coma structure. Just a faint, almost circular glow. ESA scientist Colin Wilson noted the significance. Although our orbiters continue to make impressive contributions to Martian science, it's always exciting to see them respond to unexpected situations like this. Unexpected is an understatement. Every active comet develops a tail as solar radiation pressure and solar wind push outgassed material away from the nucleus. The closer a comet gets to the sun, the more dramatic this effect becomes. 3I/Atlas was approaching perihelion, the closest point to the sun in its trajectory. It should have been developing a massive tail, millions of kilometers long, clearly visible in any observation. Instead, the tail is absent, or so faint it's undetectable even from Mars' orbit during close approach. So what's happening? Why is an active comet releasing material but not forming a tail? Let's start with what we know for certain. Spectroscopic observations from ground-based telescopes confirmed that 3I/Atlas is outgassing water vapor at extraordinary rates. Researchers described it as leaking water, like a fire hose running at full blast. For an object of its estimated size, located at 1.3 astronomical units from the Sun, this level of outgassing is far higher than models predict. Water sublimates from cometary ice when solar heating raises the surface temperature above the threshold for phase transition. At 3I/Atlas's current distance, that heating should be moderate. Yet the outgassing rate suggests either the object is much larger than estimated, or its surface is unusually volatile, or something else is driving the release of material beyond simple solar heating. Hubble observations revealed another anomaly. The spectral signature shows elevated concentrations of nickel and iron vapor. These metals shouldn't be present in significant quantities unless the comet's nucleus is being heated to extreme temperatures that vaporize rock and metal, not just ice. That typically only happens when comets pass very close to the Sun, well inside Mercury's orbit. 3I/Atlas is nowhere near that close. Yet it's vaporizing metals. The nickel-to-iron ratio is also unusual. In typical stellar and planetary formation processes, nickel and iron are chemically bound together in predictable proportions, forged in supernova explosions and distributed throughout forming solar systems. But 3I/Atlas shows nickel concentrations that don't match standard ratios. It's as if this object formed in a star system with fundamentally different chemical abundances than our own. Which brings us to the age. In July 2025, astronomers Matthew Hopkins and Daryl Seligman published a trajectory analysis tracing 3I/Atlas backward through space using data from the European Space Agency's Gaia mission. Gaia has mapped the positions and motions of over 1 billion stars in our galaxy with extraordinary precision. By calculating gravitational interactions over millions of years, it's possible to trace where an interstellar object came from and when it was likely ejected from its home system. The results were staggering. 3I/Atlas may have been traveling through interstellar space for between 4 and 10 billion years. Conservative estimates place its age at 7.6 billion years. That means this object predates our entire solar system by 3 billion years. It formed when the Milky Way was younger, when the universe contained fewer heavy elements, when stars were dying and new systems were coalescing from their remnants. This isn't just an interstellar visitor. It's a time capsule from a cosmic epoch we can barely imagine. But here's the deeply strange part. When astronomers traced 3I/Atlas's trajectory backward, they found no close encounters with nearby stars that would explain how it was ejected into interstellar space. No gravitational slingshots, no stellar flybys, no obvious mechanism for launching it on its journey. It's as if 3I/Atlas simply appeared in the void billions of years ago and has been traveling in this direction ever since. Now let's talk about the missing tail. When a comet approaches the sun, solar radiation heats its surface, causing frozen volatiles like water ice, carbon dioxide, and methane to sublimate directly from solid to gas. This outgassing creates the coma, the cloud of gas and dust surrounding the nucleus. Solar wind, the stream of charged particles flowing from the sun, pushes this material away from the nucleus, forming the tail. The physics is straightforward. The closer to the sun, the stronger the heating, the more vigorous the outgassing, the more dramatic the tail. Every comet we've ever observed follows this pattern. It's not a suggestion. It's a consequence of thermodynamics and electromagnetism. 3I/Atlas is releasing massive amounts of gas. The water vapor outflow rate confirms active sublimation. But the tail is either absent or so faint it's undetectable even from favorable viewing angles on Mars. How's that possible? One hypothesis is that 3I/Atlas is composed almost entirely of volatile ices with very little dust. When these ices sublimate, they release gas, but not the dust particles that scatter sunlight and make tails visible. The gas itself is transparent, invisible unless it's ionized by solar ultraviolet radiation or carries dust for reflectivity. But spectroscopic data shows the presence of silicates and metals. There is dust. It's just not forming a visible tail. Another hypothesis is that the dust particles are unusually large or heavy, falling back to the nucleus under its weak gravity rather than being blown away by solar wind. But 3I/Atlas's gravity is minimal. An object a few kilometers across has escape velocity measured in meters per second. Dust particles moving at typical outgassing velocities should easily escape. A third hypothesis is that the tail exists, but is oriented edge-on from our viewing perspective, making it nearly invisible. But the Mars orbiters observed from a different angle than Earth-based telescopes. Multiple viewing geometries should have revealed some tail structure. None did. So we're left with a comet that's releasing gas like a fire hose, vaporizing metals that shouldn't be vaporizing at this distance, showing chemical ratios inconsistent with our solar system's composition, and doing all of this without forming a visible tail. And it's 7.6 billion years old. On October 30th, 2025, 3I/Atlas will reach perihelion, its closest approach to the Sun at approximately 126 million kilometers, slightly inside Earth's orbit. This is the moment when outgassing should reach maximum intensity. This is when the tail, if it's going to appear, should become undeniable. But there's a problem. From late October through early November, 3I/Atlas will pass into solar conjunction, meaning it will be positioned directly behind the Sun as seen from Earth. Ground-based telescopes won't be able to observe it through the Sun's overwhelming glare. Even space-based observatories will struggle. The Mars orbiters captured what may be the last clear images of 3I/Atlas for weeks. When it emerges from solar conjunction in mid-November, it will be receding from the Sun, cooling, decreasing its outgassing. The critical moment when we could observe it at maximum activity will have passed while it was hidden from view. It's a frustrating coincidence. Or perhaps it's not a coincidence at all. The European Space Agency has announced that the Jupiter Icy Moons Explorer mission, known as JUICE, will attempt observations of 3I/Atlas in late 2025 and early 2026 as it departs the inner solar system. JUICE carries advanced spectrometers and imaging systems designed to study icy bodies. Its observations may provide the detailed data needed to resolve some of the mysteries. But until then, we're left with questions. Why is a 7.6 billion year old comet behaving unlike any comet we've ever studied? Why is it releasing metals it shouldn't be releasing? Why is it outgassing at rates far exceeding predictions? And why is it doing all of this without forming a visible tail? Let's consider the possibilities. The most conservative explanation is that 3I/Atlas formed in a star system with unusual chemical abundances. Perhaps a system where supernova enrichment created higher concentrations of volatile metals. Perhaps a system where planetary formation processes were fundamentally different, leading to ice bodies with exotic compositions. This is plausible. We know that stars vary widely in their elemental ratios depending on when and where in the galaxy they formed. The Milky Way's thick disk, where 3I/Atlas may have originated based on its trajectory age, contains older stars with different chemical fingerprints than our Sun. But this explanation struggles with the tail problem. Even exotic chemistry doesn't exempt a comet from basic physics. If material is outgassing, solar winds should blow it into a tail. Period. Another hypothesis, proposed by planetary scientists Suzanne Falsner and Michelle Bannister in September 2025, suggests that 3I/Atlas might be a planetary seed. A massive fragment of a forming planetary system ejected billions of years ago before planets fully coalesced. In this model, 3I/Atlas isn't a typical comet. It's a chunk of primordial material that never completed differentiation, carrying a mix of volatiles and refractory materials in unusual proportions. This is elegant. It accounts for the age, the size, and potentially the unusual chemistry. But it still doesn't explain the missing tail or the metal vaporization at distances where temperatures shouldn't be sufficient. Then there's the hypothesis that scientists discuss quietly but rarely publish. What if 3I/Atlas isn't entirely natural? What if some aspect of its behavior reflects deliberate modification? This is speculation. It must be stated clearly. There is no direct evidence of artificial origins. But the question persists because the pattern of anomalies doesn't fit any single natural explanation. Unusual chemistry? Possible. Extreme outgassing? Rare but possible. Missing tail? Puzzling but potentially explainable. Metal vaporization at low temperatures? Challenging but not impossible. But all of these together, in an object 7.6 billion years old, traveling from the depths of interstellar space, photographed for the first time from another planet, the coincidences begin to strain plausibility. Let's be absolutely clear about what we're saying and what we're not saying. We are not claiming 3I/Atlas is an alien spacecraft or probe. The scientific community has proposed multiple natural explanations, and extraordinary claims require extraordinary evidence that we do not currently have. What we are saying is that 3I/Atlas is behaving in ways that challenge our models. And when objects challenge our models consistently across multiple independent observations, science demands that we investigate thoroughly without dismissing possibilities prematurely. Right now, 3I/Atlas is approaching perihelion, hidden behind the sun's glare, unreachable by most of our observational capabilities. When it emerges in November, it will be departing, cooling, becoming fainter and harder to study. This is the window. This is the moment when we learn whether this ancient visitor has more to teach us, or whether it will recede into the cosmic dark, leaving its mysteries unresolved. ESA's Mars orbiters gave us a gift, the first interstellar object ever photographed from another world. Images that confirm this visitor is real, active, and defying our expectations. Images that raise more questions than they answer.
Em December 2025, 3I/Atlas viu Mac-Itis closest to Arfiet approximately 270 million km. Still too far for detailed ground-based imaging, but close enough for spectroscopic follow-up. Then em March 2026, it will pass Jupiter, receiving one final gravitational node before leaving our solar system forever. After that, It will return to the void between stars, carrying its secrets with it another traveler in the infinite dark, older than our world, indifferent to our curiosity, governed only by gravity and inertia. Unless there's something more. Unless this unseen messenger from a team before our sun carries information we are not yet sophisticated enough to recognize. Unless the missing tail, the vaporizing metals, the impossible age, and the perfect timing of its arrival are all pieces of a puzzle we haven't learned to assemble.
The Mars orbiters captured images of a glowing point of light 30 million kilometers away, a comet that shouldn't be releasing the chemistry it's releasing, a visitor 7.6 billion years old with no visible tail. And somewhere in that data, in the spectra and the trajectories and the chemical signatures, there may be answers to questions we haven't yet learned to ask. For now, we watch, we measure, we calculate, and we wait to see what 3I/Atlas reveals when it emerges from behind the sun in November. Because sometimes the universe sends us visitors that rewrite everything we thought we understood. And this ancient traveler from the cosmic dawn may be teaching us that we still have much to learn about what's possible in the vast darkness between the stars. 7.6 billion years. No tail. Metals vaporizing where they shouldn't. Photographed from Mars during its closest approach. 3I/Atlas is here. And we're just beginning to understand what that means.